notation. So remember, whatever goes in place of x is what goes into the function, into whatever your x is. So when we do our synthetic division, just like you did on that worksheet, your remainder is going to be the equivalent to what that function would have been if you were to evaluate it for whatever k is. Remember, k is whatever goes in that half box. Because in this case, it would be a positive k. If it was x minus 2, we would put 2 into that half box, which would be your f of 2. All right, so let's see it in practice. So here is an actual function. Oops, going back. Sorry. Got it? All right, so remainder theorem. If we let function f, so f of x, is equal to 2x to the third minus 5x squared minus 3x plus 11. We want to find f of negative 2. Well, in the past, what would we do? We would plug in negative 2 in place of x, right? Which would not be totally inappropriate. You could easily do that. So I'm just going to make note of what this would look like. So back when we were in our Algebra 1 days, we would do 2 times negative 2 to the third minus 5 times negative 2 squared minus 3 times negative 2 plus 11, right? And then maybe 2% of you would make some type of arithmetic error. 3% of you guys would do your order of operations incorrectly, so you might get this evaluated incorrectly, okay? Or I could just type it into my calculator. Maybe some people would forget to put parentheses around their negative when they squared it, and then they would say, well, this is what my calculator told me I would get. So, method number 1. Those are our Algebra 1 ways. But how can we use synthetic division and the remainder theorem? So, if I put that negative 2 in place of my half box and do synthetic division on this polynomial,
would it need to change over to a positive?
Nope, it would not
Okay.
need to change over. So it'd be 2, negative 5, negative 3, and 11. What am I going to bring down? Bringing down that 2. Negative 2 times 2 gets me negative 4. A negative 5 and a negative 4 makes negative 9. Multiplying gets me 18. Adding an 18 and a negative 3 gets me 15. Multiplying gets me negative 30. 11 and negative 30 gets me negative 19. Okay. So because I'm only asked to find f of negative 2, that's going to be equal to my remainder. So f of negative 2 is equal to negative 19. Now, why does this matter? Well, when I was doing this worksheet along with you guys, I was checking my answers to make sure I was correct by using the remainder theorem. Okay? Now let's go ahead and get our calculators out and let's see if we actually can type this in correctly. Wait, what? You okay? So I'm going to type this in exactly how I see it, parentheses in all. I'm going to do 2 parentheses, negative 2, close my parenthesis, take it to the third power. Minus 5 parentheses, negative 2, close my parenthesis, square it. Minus 3 parentheses, negative 2, close my parentheses, plus 11. Hit enter. Do you get negative 19? Should, if you did it right. If you didn't get that, then you're probably typing something into your calculator incorrectly. Okay. So again, why does this matter? Let me drop back to that worksheet that we just did. Can I get rid of this for a second? So back on this worksheet on problem number 8, I got my remainder to be 128. And that made me think, oh my goodness, that's a really big number. Did I really do this correctly? Well, what I did is I quickly used my remainder theorem concept. Here my divisor was x plus 2, so what was the number that went into our half box? -2. So that is your k. So then what I did on my calculator is I did 5 times -2 to the 4th plus 2 times -2 squared minus 15 times -2 plus 10. And I put that into my calculator just the way I see it. 5 parentheses -2 to the 4th power plus 2 parentheses -3 squared, or sorry, -2 squared. That would mess things up. Minus 15 parentheses -2 plus 10. Then I hit enter and I got 128. So I'm like, oh, okay, I must have done that right. Okay, so that's why the remainder theorem matters, is because you can check your answers that away. Okay, does that make sense? Remainder theorem? All right, so then the last thing that you have to be able to do is to decide whether, how did that pop down to the next line? You have a 0 of a polynomial or not. Okay, or you'll be asked that question, is blah, blah, blah a factor of the function? So what are we looking for? So we're looking to see if we have a 0 of a polynomial function. And we will have a 0 of a polynomial function when that value of k results in f of k equaling 0, meaning my remainder is 0. So your remainder is 0. So right there is your remainder theorem. So value of k such that f of k is equal to 0. If your remainder is 0, then I know, and we're going to be using the word 0 often a lot here in different ways, then I know that value of k is a 0. So it doesn't get as confusing. Sometimes instead of using the word 0 of the function, we'll call it a root or a solution. So all three of those words can be interchanged. So is this a factor? Is this a 0? Is this a root? Is this a solution? They all kind of mean the same thing. Okay? So what am I looking for? I'm looking for my remainder to be 0 when I do my synthetic division. If my remainder is 0, then I know that it is a factor, or I know that it is a solution, or I know that it is a root, or I know that it is a 0 of the polynomial function. Okay? All right, so for our last example, we're going to do 2 of them, an A and a B. So you're going to be given a value, k. So we're going to decide whether the given number is a 0 of the given polynomial function. My value k in this case is going to be -5. And the resulting polynomial function is going to be f of x equals 2x to the 4th plus 12x to the 3rd plus 6x squared minus 5x plus 75. Okay, so to decide whether it is a 0, I'm going to use synthetic division and make sure my remainder is 0. Or technically, I could just plug it in and hope for the best with my calculator skills and plug in -5 in place of x to see what I get when I evaluate it. It's the same process. I feel like I would make less errors using synthetic division, so I'm going to put negative 5 in my half box. And we got a 2, we got a 12, we're going to 6, negative 5, and a 75. I do not need any zeros as a space filler because I have an exponent of 4, exponent of 3, 2, 1, and then 0. If there was a gap, then we need to remember to put in that 0 to fill in the gap. Bring down your leading coefficient of 2. Negative 5 times 2 gets me negative 10. 12 and negative 10 makes 2. Negative 5 and 2 makes negative 10. Adding gets me negative 4. Negative 5 times negative 4 is positive 20. Adding gets me 15. And that gets me negative 75. Right? Yep. So that gets me a remainder of 0. So is negative 5 a 0 of the given polynomial? Yes. So we would say yes, it is. Because my remainder was 0. Okay. So again, what does that technically mean? That means we have that being a factor of it. So if negative 5 is my k, what would that look like as a binomial factor? This is going above what you're going to have to do for your homework, but let's think about this for a second. What would that look like in parentheses if negative 5 is one of my zeros? Work backwards. Go back to chapter 7 or 6. If I had my solutions were negative 5 and 3, what were my factors? This would be an x plus 5. This would be an x minus 3, right? We think backwards. So if negative 5 was one of my zeros, then one of my parentheses was going to be x plus 5, right? Yeah? Is everybody following that? Yeah. And then what would be left over? Well, I would have this down here, which was 2x to the third plus 2x squared minus 4x plus 15. Maybe that could go further. I don't know. Possibly. We'll eventually be getting here. That's the end of chapter 12. Just giving you some foreshadowing. All right, let's do a B. I did not make a B. It still is A. I make that B. So the number we're checking to see if it's a 0 is negative 4. Your function is f of x equals x to the 4th plus x squared minus 3x plus 1. Do we have a gap in that polynomial that I'm going to need a 0 for a space filler? Yes, at the 3 mark. So negative 4 is going to go in the half box. 1, 0, 1, negative 3, 1. Go ahead and do your synthetic division. See if you can beat me to the punchline. Bring down your 1, negative 4, negative 4, 16, 17. My goodness. What is that? Negative 68. You guys got any giant number? That's 4 times 71. You guys getting 285 for your remainder? Okay. So again, if I didn't trust my synthetic division, what I would then do on my calculator is I would do negative 4 to the 4th power plus negative 4 squared minus 3 times negative 4 plus 1, and I get 285. I'm like, oh, okay, good. I know I did that right. Just to give myself some reassurance that I'm not messing anything up. So is negative 4 a 0 of that polynomial function? No. Okay. All right, so that's all you're going to have to do for your homework. So you're going to have some problems where you're asked to find the remainder. So use your synthetic division to evaluate it, and then use synthetic division to determine whether something is a 0 or not. Questions with that? Easy enough?